Hey, this is Bill. I'm checking in with Paul McWhorter's homework number 36, where we started in with servers on the Pico W, and the homework assignment was to kind of control it with a potentiometer. So hopefully I did what he asked. Um, you can see here's my setup, and I think the setup was essentially the same as well, I guess we didn't have a potentiometer, but you can see I hooked up the potentiometer. The middle pin is the read, and that's that red wire that kind of goes horizontally. And I put that in number 28, and this is kind of weird because this is from a previous project, and I just left it there. I mean, it was still on the breadboard, so I've got several breadboards and just moved the Picos around. But anyways, that's it. And then you can see, I believe that's pin number 15. We've got the servo on, which Paul did, and then the other wires run up there. I didn't maintain color through the whole thing, but the blue and the white one are ground and power respectively. So anyways, that's that setup. And then if you kind of look down on the lower right side, I did some math that Paul likes. And I always draw the graph. It just makes it easier for me. But anyways, I plotted the pot value against the server duty range. And in the lecture, in Paul's lecture, he did the math to come up with the 1638 and the 8191 based on 50 hertz and the half a millisecond read time. So anyways, I figured out the slope, and I did the Y1, Y2. I kind of going through this fast, but you take the pot val reading, and then that should give us the servo duty. And then he wanted to know the angle, and this would work without doing that, but anyways, just to calculate the angle, I ended up doing the lower graph and with the slope, and you can see the server duty was the same numbers as we had previously, although this time I put them on the x-axis, and the servo angle from 0 to 180 degrees on the y-axis. And so you can see there's my math from there. That was the stuff that I thought needed to be tackled in order to solve this problem. Now we'll go to the code. For machine, import PMW, pin, import time, and then here's the stuff for the servo. And with the minimum max that, like I say, Paul calculated that. Here's the 1638, the 8191. You know, we did servo, machine, PMW, machine dot servo pin. Servo frequency was 50. Again, that was from Paul. And I meant to do this, and I didn't. But anyways, because I remember in a previous lecture, homework assignment, Charlotte had a way where she could just hook the potentiometer up and move it through its paces, you know, maximum right and left, and it would just record the high and low. What I ended up doing was I did this pot val equals pot dot read. Well, rewind a little bit. Pot pin was 28, and that's the one up here that I said I'd just copied from before, you know. And then pot equals machine, and that's an analog to digital converter, and it reads from the pot pin. This is stuff that I wanted to print out just to check it, make sure everything was good. So this is the header line, servo angle, servo duty, and pot value. And then here's the while true. This is the power loop part of it all. Pot val equals pot dot read, and so that's calculating the pot val. And what I ended up doing to come up with these numbers over here, or I'm sorry, the pot value numbers are up here. What I did is I just printed out the read and just looked at it. The 65,535 remained constant. If you turn it all the way full blast, that's what it's at. The zero end was a little different. It bounced around quite a bit. I took the high and low from what appeared to be the ranges of those bounces, and I came up with 232 is what I used to kind of make it a little bit more excuse me, a little bit more accurate. So then we come down here and I figure out the servo duty and the servo angle, and here's the equations that I showed you the work for. And then we have servo.duty, and this took me a while to figure out. This would not work unless I put int in there, and I spend more time than I want to. And then going on, I looked this back up because it was kind of nice. Here's the degree symbol, and this /r, and then end equals parens here, or quotes. Makes it so it doesn't scroll a million pages down on the shell here. You can actually just take a look at it. So you can see it's up and running right now. The servo angle, currently I'm not touching anything, but you can see it's bouncing around from 12 degrees. There's the servo duty number, and then there's the pot val. And let me go over and I'll kind of show you how this works. If I turn it all the way down, the servo angle is, you can see there's a negative one in there every now and again, but it's very close to zero. And you can see the servo duty is very close to that 1638 that Paul calculated. And the pot value, you can see that bounces around, but you know, hopefully it centers around my 232. And then you can watch the servo go. I turn it, let's see if we can get it close to 90 here, 80, yeah, 89, 90. So you can see that's halfway. The servo duty falls in the middle of where you'd expect it. The pot value, same type of a deal. Then I'll move it all the way to full blast to the 180, and you can see servo angle down here is very close to 180. Servo duty 8191 is it's hitting that, and the pot value is at its full 16 bit. I don't know what's going on here. I need to figure out the spacing here. But anyways, you can see it's the 65,535. And I could probably round these off and make them so they don't bounce as much. But anyways, that's my homework. Hope it helps. This wasn't a horrible one.